So we made a wedding band that's not a wedding band. It just fits on my ring finger. So
But he
we'll
made
walk.
it for his ring finger, so it's kind of a
Yeah.
lie, technically speaking.
So we'll walk through the process of designing the ring from start to finish. 3D design, casting, smelting, pouring, polishing. So as any good ring is created, we started in Grasshopper and Rhino. First by figuring what size we want. Size 7.5 for my ring finger. And I'm using Peacock, the jewelry plugin, to do that. So we started off making a circle for the ring and then making the outlines of the design itself. We're using pufferfish with twisted boxes to make this kind of bone pattern on the band. I combined two different patterns from the Mesh Plus plugin with the twisted boxes to create more unique pattern. Going off of that, I wanted to add some human people into this design. So we're in Blender now. So we're using the Human Gen plugin to add a human to the file. With Human Gen, we can pose the figure however we want. So I wanted two people kind of hugging, embracing on the ring. So we're starting with the first person here, duplicating them and adding a second person. And then it's just going back and forth between all their bones and moving the hands and the feet and the head to be in the correct position. And once we have that, we can bake it down into just mesh that we can then re-import back into Rhino to finish with the sculpting process. And then once we're back in Rhino, they're sitting in the band, and I wanted a way to add something to the other part of the ring. Going off the idea of this being a wedding band, I wanted some central motif to the ring. So we have the people on one side, and then we have this more sculptural sinew piece on the other side, holding them in position. So I'm using some tween curves from pufferfish again to add the curve structure, and then using a custom tool that I made for Grasshopper, I can actually add the connection curves into the overall form. So there's only like 4 base curves here, and then the rest of it is all procedurally generated. Once that's all together, we can use the Dendro plugin, which is a voxelization tool, to mesh everything together into one watertight piece. And I've got a bunch of sliders here just to play around with the actual construction of the curves. So once that's all together, we can export this as one solid mesh. But before we slice, I just want to clean this up one more time. So I brought the entire mesh back into Blender, and we're using the sculpting tools this time. So I can go back and forth between the smooth brush and the thicken brush and just make sure all the details are sculpted in well and everything, all the detail is clear so that the print goes well and then the cleanup goes well. So once everything's sculpted and I like how the final mesh looks, we can actually prepare this for printing and casting. So the first step is to actually add the sprues, but we've constructed a custom tool in Grasshopper to add the sprues automatically. So I just have to set the base points on the rings, and then that'll create the sprue that'll work well when we start casting. So with the 3D done, we actually have to set it up for printing now. So we have to make sure all the supports work well. I'm using Lychee Slicer here to add those supports. One thing about the free version of Lychee is it doesn't have some of the more advanced settings like breakpoints, and those just make it easier to remove the supports later on once we've printed it. So we made another custom Grasshopper tool to add those breakpoints. So once that's all together, we can re-import that into Lychee, do the actual slice, and then we're good to start printing. So here's the printing as it finishes. So we're using a Soraya Tech, what's it called? Get the bottle.
This is a Shiro Tech cast in purple.
Oh
1,000,
yeah, okay. So
1,000 grams. So.
Soraya Tech has the blue and the purple option, and we're using the purple here. So once the print finishes, we have the custom supports, and we also have the name of the file around the base, which is just helpful for when we print multiple different rings at once. And then we have to remove them all. So before we cure it, we just want to make sure we remove all the excess resin.
Yeah, it's just like kind of gunked up in general. But it takes all those defining features away, so it's quite the problem. So we use compressed air and alcohol. Alcohol helps as well, just to clean that up.
Yeah, so we have a alcohol wash machine, and then we're just curing it under a UV lamp here with a turntable. Doing it by hand gives us higher detail instead of using the machine to cure it. So we can actually cure it in multiple different iterations.
And I also do quite a bit of cleaning up before the curing process, so it's still soft. And when it's still soft, you can cut through things a lot better. You can break off all the supports a lot better. So you gotta really like make sure to clean it up to the part that you want it to, and then cure it, because that's when it gets hard. And then on top of that, if you do cure it after it gets hard, when it does get hard, you can actually sand it.
But it's cool to see it close up, see all the details before we go to casting.
It's necessary.
So we're using a lost wax casting method. Basically, we'll put the wax into a mold, and then we'll burn the wax out in a kiln, and then we'll pour metal in its place. So this wax does not exist anymore. This has been burned out to give us the actual metal ring.
This is actually from a fail, so it's kind of funny to see it in this video. That was a successful fail.
Yeah, so we don't have much of the pouring process recorded because it goes so quickly, but Basically, we're mixing up casting powder with water with a certain ratio.
But for the powder we use specifically, you take like the gram and then you divide that by 2.5, and that's your water ratio. So it's the powder to water. So we kind of initially ran into this first issue of, came with this like thick metal piece, but it's too big for our centrifuge casting device. So we weren't actually able to use it whatsoever. So then we had to kind of invent our own little kind of molds. You can see it's still full with a bunch of clay in there. But oh well. But yeah, so we kind of had made these certain things. This is what, 3 inches tall?
Yeah, it's
4 inches
80,
tall,
80
almost.
mils.
Yeah.
Yeah.
And this just fits perfectly inside that same rubber piece. It's a tight fit too, because you need to be watertight when you put it in the vacuum chamber.
Mm-hmm.
But so you kind of just throw that on, and put that gram powder to water ratio. Put it in this vacuum chamber, the whole thing. And then this is what we pour into. Actually, you see in the videos. We initially started with these collars that I made. And the issue with the collars is it was thin metal, so the more you heat it up, because we go almost to 1,000 degrees for 2 hours. So when you do that, it kind of just started weakening that metal over time. So we had to step it up to something thicker. And on top of that, the collar was nice because you can put it like all the way around and then tighten it down. So that's cool. It's kind of like you can kind of take it on and off, and it kind of saved us in this cast in a way. The one that you see kind of like our fail. So we kind of made these, and this is actually an exhaust pipe from Advanced Auto Parts. Yeah, hot tip, if you need some 3-inch pipe and you can't go find it at Home Depot, it's at Advanced Auto Parts. So that's kind of like our solution to that problem for that style of centrifuge.
So we'll take a look at the centrifuge in a few minutes, but there's 2 ways you can cast. You either have the vacuum casting, where you put your whole thing in a vacuum and then pour straight in, or you use a dental centrifuge like we have, using momentum to throw the metal back in there.
Yeah, and that's our vacuum. And that's actually our initial plastic, kind of how we 3D printed that part, and that's kind of the same size as our metal collars are now from our exhaust pipe. And we did that whole method in particular to then transfer over to those metal collars, which was an interesting process. It was kind of like an extra step, but it didn't work as good as just doing it in a solid form metal. It should be in the same thing the entire time. And that's what you get when you don't put it in the same mold the entire time. You get all that cracking.
But our setup's pretty simple. What do we have? A
glass kiln. Glass kiln for fusing glass.
And then the metal melting furnace.
Which you probably should buy. It's way harder to do it by torch.
Yeah.
I would not recommend.
So the aluminum in this clip melts at 660 degrees Celsius. So the torch melts it pretty easy, but it still takes a lot of energy to keep it melted long enough to pour it.
Torch really only works when you're trying to solder small joints together.
One thing we didn't mention too is figuring out the amount of powder to pour initially.
Yeah.
And we have another grasshopper tool that measures the volume of the 3D model and calculates how much powder we need. I mean, this is silver in the video,
It is.
but it's just showing that you can also measure out the metal the same way we measured out the powder. Yeah, putting the metal in the furnace. I think that's probably at 1,000 degrees Celsius. But
it's at 1,100.
1,100. But it melts pretty well here. If this was aluminum, it would melt much quicker too.
Yeah.
Which is what we use for the final ring. But that's a very scientific way of knowing it's ready, is when you shake it and it moves.
Shaking.
You're ready to go. But we can see a hot mold there getting ready. Oh, so this is the fun part. You want to explain the setup? Because you kind of designed the setup.
All right, so I country designed the setup. All right, so we kind of started off outside. We moved it inside just because it's currently winter. So we moved it inside, and I metal sheeted kind of like that whole backdrop. You can see that big sheet of steel in the back. We built this hood, and this hood sucks all of those fumes out a window. So that kind of helped quite a bit.
I think, yeah, main point, make sure it's ventilated.
Yeah, ventilation is big.
Yeah, so
big
get that
problem,
exhaust.
big problem.
See, the exhaust hood helps a lot.
On top of that, we kind of had some mounting things with the centrifuge. The centrifuge technically isn't like perfect, so I built that. That's actually on a metal sheeted base and screwed in, and then I also put screwed in spikes that go all around it, so it kind of has cleats.
So we wound it up 3 rotations, and that's going to give it a lot of energy once we release the brake and just let it spin.
And then at that point, we're just kind of, you see us put those 2 things on. Both of those are heated up in that glass kiln. The crucible itself, which is that little like centrifugal crucible, those are both heated up hot because, and this is kind of the issue you think about too, is you can't really have too hot of a cast. You can't really have too cold of a crucible. You have to be like perfect temperature on both of those because you need to have a hot crucible, probably hotter than the mold itself, just so it keeps that metal liquid the entire time. And then you want to have somewhat of a cooler, but still hot cast, because once it goes in there, you don't want it to stay liquid.
And then you're going to the kiln to get the graphite.
Wear gloves.
Yeah, definitely heat gloves are good. So Tyler's grabbing the metal. I'm keeping the ceramic crucibles hot with the MAP gas. And then we'll fly the metal in and get that poured.
scientific shake. That's
Yep.
what you just saw.
And we're keeping it hot the whole time. Yeah, make sure you put it back.
Yeah, you gotta put it back. Don't put it on the ground.
That's a bad idea. You'll keep it hot and then release the brake in it. Go for a good ride. And I did not include the fail in this video, but
We never failed. We've only ever been successful.
yeah, you want to make sure the weight is equal so this thing doesn't jump around like that.
Ah, it's clever. It's clever.
Uh huh.
Can't let them know your next move.
Mm-hmm.
Then we're just taking all that apart too, and you see a struggle a little bit here because there's a little bit of like side pour on that, so that aluminum kind of like sticks to the mold itself.
Yeah.
It's hot. That's
Yeah.
why you wear gloves, kids.
Yeah. Don't touch the metal. It's very hot, and you'll see that in the next step here. So once we dunk it into cold water.
That's water vapor, by the way, not toxic chemicals, but don't breathe it nonetheless.
Yeah, definitely wear some PPE. But since it's so hot, the entire thing kind of just combusts under that water.
It does.
The powder disintegrates, but the metal is fine, and it's just down there somewhere.
Yep. And this is a relatively small casting too. We usually do them a little bit bigger, but just for the case of the video, just 2 rings.
Yeah, just 2 rings. Yeah, so all that powder gets stuck in there. Well, not all the powder. A little bit of powder gets stuck in the ring that we just have to clean out manually, but most of it breaks away instantly.
And all I did is this is an X-Acto like pen, and then I just put a sewing needle in the tip of it, and that's just like my poker. So I'll just go around and poke the entire thing.
Yeah, so everything here on is just the cleanup process, right?
Yeah, yeah. Then once I'm done poking, I'll just hit it with that compressed air really helps in a lot of things. Just because he'll decide to make something extremely complex. The stuff that I make is a little bit more doable, but his has a bunch of holes, pits, and everything.
Yeah, a bunch of internal volumes here that you have to clean out.
So you can see me here kind of cleaning up the initial bit with these little files, and then the little time lapse that comes in here. And these are all kind of like, the same kind of tools that a lot of jewelers use. Mine are probably a little bit like cheaper in general, but they still work just fine. I wouldn't recommend the wire brush as much, but there's definitely like a scenario to where it's probably the better option when you have like a lot of like pitting, like major pitting and stuff like that. And do it in cross sections too, so it doesn't just gouge. It's a big problem too. You can gouge with that wire.
Mm-hmm.
And I'm really just using wet sandpaper to take those initial kind of divots and dimples out. And I'm using that with a polishing agent as well on top of that sandpaper, just as my wet part of that sandpaper. I'm using an aluminum polish, like Mother's aluminum polish. It was like a thing I had back in the day, so I just kind of like pulled it out. And then on top of that, then my buffing wheel that I have on that Dremel is just this green compound for polishing. And it's kind of how you get like it overall pretty clean, and you can kind of wipe it off with paper towel, stuff like that. And then you see me do that bath at the end to take all that gunk off because it's all oily and whatnot. So that's how you get it kind of clean. And so these are a little harder to clean up too. I mean, you're just not going to get the best shine and get all those. You really need like a giant hair wheel. And we've yet to get a hair wheel, so that's going to be something maybe in the future for our future aluminum proofs. But then again, it's all really easy to work with because it's aluminum proof, everything, before you cast in silver. So silver casts a little bit better. The aluminum tends to pit a little bit more, and it also tends to cold crack. So on some of the finer things, some other failed rings that are just like super thin, there's a lot of cold cracking. You can see this one kind of comes apart.
Yeah, that's the whole process then.
Yeah, pretty much about it. Yeah, hopefully you learn something.
Hopefully learn something. Yeah.
So we're just out here making stuff, and that's what we do. So
We're just trying things.
try something new.
Mm-hmm.
Try something new
Try something new every day.
every day.
Yep.